Okay, before we get back into the graphing, let's talk about writing equations with given information. So I'm going to write the simplest possible sine equation here. So here's what my basic format is going to look like. I'm going to have the amplitude first. Then since it's a sine equation, I'll have sine, right? And then I'll have my k. And then the theta will go like this. The k could go inside of the parentheses too, but it's got to be somewhere in this slot, okay? And then I'm going to be adding my vertical shift or subtracting it if it's negative, okay? So this is the basic format that I'm looking at. So a lot of these parts are pretty straightforward. You just have to know where the pieces go. That's going to be a 9 there. Okay, I'm going to leave the k alone because this is the part, this isn't just going to be 7 pi here for the period. It's going to be something else. So I'm going to leave that and leave a little space there. The vertical shift is down 8. Okay, so these are the easy parts, I think, the amplitude and the vertical shift. You just have to know where to put them and then plug them in. Okay, and the k isn't necessarily difficult. It's just easy to make a mistake on it. It's not just going to be 7 pi. Okay, so what we want to do here, we think, okay, if my period is 7 pi, all right, and then I know my period is also 2 pi over k. Okay, so now I can say, well, 2 pi over k must equal 7 pi, all right? And now I want to solve this equation for k. So say 2 pi over k equals whatever your given period is, okay? So 2 pi over k equals the period, and that's going to happen for sine and cosine. It's 2 pi over k equals whatever, okay? And then we can solve for k here. I'm going to use the incredible switch, which I've talked about in previous videos, when you have a fraction equal to something else. When you've got a variable that you want to solve for in the denominator of a fraction, you can just switch those two. So 2 pi over 7 pi is going to equal k, and then the pi's will just cancel. So k then is going to equal 2/7. So that's the missing piece in here, 2/7. And again, you could have that inside the parentheses there, but you'd want it in between the sine and the theta. And there is my equation. Okay, I like to keep the k outside of the parentheses. It makes it easier when we later on when we've got phase shift in the mix as well. Okay, all right, so let's try another here. I've got cosine, so I'm thinking, okay, y equals my amplitude is 13. I'm going to just write cosine instead of sine. I'll leave a little space. I'll get back to the k. I'll do the easy parts first. Down 7, so there's a -7. Okay, all right, so let's figure out what goes in that missing slot then. So again, 2 pi over k equals the period. So now I can say 2 pi over k equals 2/3. Okay, and I can solve for k. So we can cross multiply here. 2k is going to equal 6 pi, and then divide by 2. And I'm off screen. There we go. All right, k then equals 3 pi, and then that is the missing piece there. Okay. All right, so vertical shift is when we're moving the curve up or down. It moves the midline up or down. We haven't moved our curves left and right yet. That's going to happen with something called phase shift. So you might think that this would be called horizontal shift, but it's not for trig functions. It's called phase shift. I don't know why, but that's what it's called. But this is going to move the curve either left or right, depending on the situation. Okay. All right, so let's take a look here. We're going to graph this. There's not a lot going on, but I do have this new part, right? We haven't added or subtracted inside of the parentheses. If we had something added or subtracted outside at the end, that would be a vertical shift. But this is going to correspond to a phase shift, okay? So just before I even get to the phase shift part, my amplitude is going to be 1. My period, well, k is going to equal 1, so that means the period, since it's 2 pi over k, well, 2 pi over k 2 pi over 1 is just 2 pi, so it's the same period as my parent graph. Okay, my vertical shift is 0, so that means the midline is going to be on the theta axis. Okay, all right, and then this new bit. All right, so for the phase shift, here's what we want to do. You're going to want to set the parentheses equal to 0. Well, the contents of the parentheses. Okay, and then we'll solve for theta. In the same kind of way we've been doing with many different equations over the course of the year. Okay, so theta plus 3 pi over 2 is going to equal 0. Didn't leave myself a lot of space here, but I'm just going to subtract 3 pi over 2 from both sides. Whoa, what am I doing there? Okay, so that means my phase shift here is going to be negative 3 pi over 2. And since it's a negative, that means it's going to move to the left. Okay? So my phase shift for this particular one you could either say negative 3 pi over 2 or left that much, left 3 pi over 2. Okay. All right, so this gets a little bit more complicated because we're going to have to deal with the period. We're going to have to scale the theta axis and move things left and right. So these are the most difficult ones. That's why I saved this for last. Okay, so I've got some steps for you to take when you've got all the components. So first, we're going to make what I call a roadmap using the vertical shift and amplitude. I'll show you what I mean by that. So that means I'm going to, on my graph here, I'm going to sketch the midline. So I'm looking at my vertical shift. My vertical shift is 0, right? So that means my midline here is just going to be right on. And I'm going to do that with a dashed line, okay? And then, so I would do this lightly because it's not part of my final graph, but it's just going to help me to graph. And then using the amplitude, well, the amplitude was 1, so that means I'm going to make a horizontal line that's 1 above the midline and also one that's 1 below. So then I know all of my critical points are going to be on these 3 horizontal lines, okay? And you can see why I call it a roadmap, right? Pretty clever. In fact, you know what? I made this up, roadmap, so I'm going to trademark that just in case. There we go, okay? Just so no one else can get rich off that. Okay. All right, so now we're going to sketch what I call the ghost curve. So I'm thinking this is a sine function, okay? And there's no reflection. It's not flipped upside down. So very lightly, I'm going to think, okay, well, the basic shape of a sine function, I'm going to not worry about the phase shift at all. So it's kind of, what would this look like with no phase shift? It would look something like that. Okay, so I'm calling this my ghost. Okay, so just going down these steps here. Now I'm going to scale the theta axis using the ghost. Okay, so here's where the period comes in. So my period for this one, sorry, I should get this all on one screen, but my period was 2 pi, right? So that means that's the length of one cycle. So, hey, using this ghost, then I know this fourth tick is going to be 2 pi. I'm going to put that outside the roadmap so it doesn't get in the way of any points I'm drawing, okay? But that's that fourth point, okay? And now I can scale all of these, right? Halfway to 2 pi, well, 2 ticks is halfway to 4 ticks, so this would be 1 pi. And then halfway to 1 pi would be 1/2 pi. So each tick is a half pi, and I could label all of them now if I wanted to, right? And I might do that later, but that's enough for now, okay? So we've scaled the theta axis, all right? And now we're going to move the curve left or right, okay? Now, the phase shift that I have on this problem is right here, that tells me that this ghost curve is going to be moved to the left, okay? So you can't really move it 3 pi to the 2 left before you know what your scale is on your theta axis, okay? Now, this can be a big pain if you're not moving an exact amount of ticks left or right, but I'm going to give you problems in my class where you are moving either 1, 2, 3, or 4 ticks to the left or the right, okay? So I'm thinking about this 3 pi over 2. What does that mean on this graph? Okay, well, if this is 1 pi over 2, 2 pi over 2, 3 pi over 2 means 3 ticks, right? If I'm counting 1, 2, 3 ticks. So that means I'm taking this whole thing, but I'm going to move it to the left 3 ticks. So I usually start with just the leftmost point. And I'm just going to move that 3 to the left. 1, 2, 3. Okay? And then from there out, yeah, I could do that same thing with all these points, but I'm just going to follow the sine curve pattern. I go up, middle, down, middle, right? So from here, now that I got this started, I'm going to go up, middle, down, and I'm staying on the road map here, right? And then this is what it's going to look like, okay? So then now I've moved the curve to the left in this case using the phase shift. And the last thing you'd want to do is to label the start and end of your cycle. Okay, now this goes on forever, but we just need, so this will tell me if I'm looking at your test or quiz, if you label the ends, then I'll know you know what the phase shift was, and I'll know you know what the period was. Okay, so you don't need to necessarily label every single tick, but you'd want to label the start and end of your cycle. Okay, so I've already got the end labeled as pi over 2, so let me just emphasize that there. Okay, and then I know each tick is pi over 2, so I'm going 1 pi over 2, 2 pi over 2, 3 pi over 2 to the left, and since I went to the left, negative 3 pi over 2, and there we go. Okay, and there's my graph. Okay. Okay, let's try a couple more of these on the next page. All right, so got lots going on in this equation, so let's just start gathering some info. So my amplitude is right here. So my amplitude is 2, okay? K is 1/4. That doesn't give me the period in itself, but remember the period is going to be 2 pi over K. So I've got 2 pi over 1/4. Whoops, not 1/2, 1/4. Okay, okay, well, I can do something with this. 2 pi over 1/4. That's 2 pi divided by 1/4. Okay, and that means that's 2 pi times 4 over 1, or times 4. So that means my period is 8 pi. Okay, got my amplitude, my period. Hey, this is the vertical shift. So you could just say 3 or up 3. And then the last piece is the phase shift, and that's where I take this and set it equal to 0. My phase shift isn't negative 4 pi because I have to take theta minus 4 pi, set it equal to 0, solve for theta. So it's actually going to be 4 pi. So that means I'm going to move to the right, okay, since it's positive. Okay, so I'm going to start with the road map. So the road map, I'm kind of looking at my vertical shift first. That's going to give me the midline. I always find the middle of the road map first. So up 3. Let me do this highlighter here. Okay, up 3. There's the middle of my road map. Then I'm going to use the amplitude to find the two sides of the road. So I'm going to go up 2 from there, and then also down 2, and then I'll make 2 more horizontal lines. All right, there is my road map. I just need to stay on those 3 lines for my critical points. Okay. So next up, I'm going to do the ghost. So I'm thinking cosine, and there's no reflection because there's no negative out there. So cosine, you need to know the parent graph. The parent graph shape. There is my ghost. This is what it would look like if there was no phase shift, okay? And the reason you want to do that, you don't have to draw the ghost, but I think it's helpful because then it makes it easier to visualize, okay, this is going to move to the right. And also, we want to scale the theta axis. I know I'm going 4 pi to the right, but that doesn't necessarily mean 4 ticks. I got to figure out what each tick means on this graph. That's where the period is going to come in. So now visually I can see, okay, a period is going to be the length of one cycle. So that means that this 4th tick out is going to have to be 8 pi. And since I know the 4th tick is 8 pi, now I can figure out what 4 pi means on this graph. All right, so I'm thinking halfway to 8 pi is 4 pi. So that means on this graph, 2 ticks is equivalent to 4 pi units. Okay, so that means everything's going to move right 2 ticks. Okay, so I'm going to take my leftmost point and I'll move that to the right 2 units. And then I'm just going to follow the pattern of the ghost. So I'm going to go the top, middle, bottom, middle, and the top again. And this is what my cycle is going to look like. Okay? So I want to label the start and the beginning. On the theta axis, the start I can already see is 4 pi. Okay? And then, you know, halfway to 4 pi is 2 pi. So each single tick is 2 pi. So 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. This would be 12 pi then at the end. Okay? And now I've labeled where my curve starts and ends, at least my cycle. Okay? All right, let's try one more. I've got a sine curve this time. Let's see. Vertical shift, that's right here. So -1 or down 1. And then amplitude is right here. So my amplitude is 2. Period, I'm going to use this as k. Okay, so it's 2 pi over k. 2 pi over whatever k is. Okay, and this is the same as the last problem this time. So I've got 2 pi divided by 1/4, and that means 2 pi times 4, 8 pi. Okay, so my period is going to be 8 pi. The phase shift, I'm going to take all of this. It's not just going to be -pi. Don't just change the sign of this. Take everything that's inside the parentheses, and that's all going to come into play. So the 1/4 is going to affect the phase shift here. Okay, so I'm going to subtract pi from both sides. I'm trying to solve this for theta. Okay, and then to get theta by itself, I'm going to multiply both sides by 4, because 4 times 1/4 is 1, right? So then theta will equal -4 pi, and that means I'm going to be moving my graph left this time. Okay, the vertical shift, that means down that much. Okay. All right, so now starting with my road map, I'm going to do the midline first. That's coming from the vertical shift, so down 1. Okay, and then I'm going to use the amplitude together with that. So the top of my road is going to be 2 above that. The bottom of my road is 2 below. Here is my road map. Okay. Now I'm going to draw my ghost curve. This is a sine curve, so I'm thinking about the parent graph for sine, and I'm just sticking that on this road map lightly. Okay, there's my ghost curve. I'm going to move this left, but before I move it left, I have to scale the theta axis because I don't know what 4 pi means on this graph yet. So let's see, 8 pi. So one cycle is 8 pi. That means that 4th tick out is 8 pi. Okay, halfway to that is 4 pi. Halfway to 4 pi is 2 pi. So each tick is worth 2 pi here. And I'm moving 4 pi to the left, which I can see, hey, 4 pi is 2 ticks. So going 2 ticks to the left. Okay, so I'm going to take my leftmost point here. Move it to the left, and then you could move each point to the left, but I'm just following the pattern from there, going up, middle, down, middle, up. And there we go, there's one cycle. Okay, and last thing is to label. Already got the end labeled at 4 pi, and each tick was 2 pi, so I went 2 pi, 4 pi to the left here. So my cycle stretches from -4 pi to +4 pi. Okay, and that's it for today. See you next time.